Hi, my name's Will Law. I'm an engineer here at Akamai, and I want to talk to you today about a project we're working on at the Dash Industry Forum around content steering for MPEG Dash. I'm going to be looking at why we even need content steering, how we might implement it in the Dash manifest, and then what it looks like in a demo. And finally, we'll go through how you might get involved and be able to add a contribution to content steering itself. So let's kick off with why we even need content steering. Media, when it was first distributed, was done from a single CDN. So here I have a cloud provider, which is the origin, a single CDN, my green one, CDNA, and I give the Dash player a manifest that is pinned or pointing at this content. So it'll start off playing content from CDNA. If there's some sort of interruption or slowness on that delivery, there's going to be rebuffering in that player. And there's nothing you can do about it because that is its only source for content. The obvious solution to this problem is give the player two CDNs, and this is the advent of multi-CDN distribution. So now we have CDNA and CDNB, both referencing a common origin hosted on a cloud provider. We then give the player two manifests, one pinned or pointing at manifest at CDNA and the other at CDNB. The player might start on CDNA. If there's a slowness with CDNA, there would be a rebuffer period while it switches manifests and switches over to CDNB. This is a discontinuity for the end user. It's unpleasant for them to see, and it's not ideal either. So to solve that problem, Dash added base URL. So base URL is basically an ability within the same manifest to give the player two possible sources to retrieve the content, CDNA and CDNB again. So here we have the player starting on A. There's a discontinuity or problem with the throughput. It rebuffers, but it's able to switch over far quicker and more smoothly over to CDNB because it has all the information in the same manifest. And this may seem, again, a solution to the problem of slowness. But let's look at why this might be a problem on a large player population, say hundreds of thousands or millions of players. The trouble is that when a Dash player fails over, it's quite indeterminate. There's all sorts of behaviors in the wild. Some will retry 3 times after getting a 404 and then try the same bitrate, then switch down to a lower bitrate. Others switch bitrates immediately. Some will try the base URL immediately and never go back to it. Others will re-request content indefinitely. There's no defined behavior in the Dash spec for how the client should react to different delivery problems. So the behavior in response to slowness and lower buffer levels is completely undefined and not predictable amongst a large cohort of players. And you can see this problem. Imagine we have a lot of players connected in our multi-CDN distribution to two CDNs. They all start off playing the preferred CDN, which is A. And then there's some sort of slow problem with CDNA. And what will happen is some of the players will switch over to B. Others will try to recover and stick on A. So now I have a spread of my population, some of which are playing on A and some of which are B. So large player populations are not deterministically controllable in the face of CDN slowness. Now, why might content distributors want to switch CDNs? There's a number of reasons. We've looked at the obvious one, which is performance. CDN performance and capacity is not constant. It's varying all the time, and it might be good 1 minute and bad the next. It's also bad in a network, in an AS, and then not in another network within the same city. We don't want to start new users joining a session on a bad CDN, and we don't want to keep existing users on a poorly performing CDN if there was another CDN in their network that was performing better. Capacity is also an issue. A CDN might have lots of capacity when your event starts, but midway through they start delivering a lot of somebody else's traffic and their capacity diminishes. This again will vary with time. There's also volumetric constraints. People sign contracts where one CDN must get a certain percentage of the traffic, and this fluctuation can vary geographically as well as temporarily. And finally, there's the big driver, which is cost. CDNs can change their price both in geolocation and by time of day, and you might want to be minimizing your distribution costs by intelligently switching between CDNs. So a lot of reasons why content distributors want to manage how their players switch between the available CDNs. Here's a real-life example. This is an admittedly very complex diagram. It's not important exactly what's in there. We're looking at distributing content from the United States to South America. And we got an end user here in Santiago in Chile on Telefonica. We noticed that they only have 51 milliseconds of latency to serve them out of an edge region in Brazil and 150 milliseconds of latency to serve on a CDN that might be serving out of US East. So in that case, we would prefer to serve them out of Brazil. Here in Lima, Peru, on someone connected via Claro, we have 127 milliseconds to Brazil, so they're poorly connected. And in fact, this case, we would actually want to serve them out of the eastern United States. So there's intelligent routing decisions that also make sense for different CDNs that have different presence within different ASs. You might also look for data. Does throughput actually vary much by your ISP or how you're connected? And ISPs are also important because CDNs have different points of presence within ISPs. So here I looked at a 2-minute sample of 19 million requests for a big OTT provider here in the USA. And I've just listed all the different ISPs alphabetically, A to Z here. We can see, and I scaled them by the amount of traffic they were delivering. And on the vertical axis is the throughput. So we can see there's a large variety. Some of these smaller ones performing very well, some of the larger ones performing well, but some ones that have a lot of users performing rather poorly too. So where you are, how you're connected to the internet makes a big difference on the quality you're going to receive. And CDN performance does vary by time. Here's some data courtesy of Paramount, where they monitor their multi-CDN over time. And we can see in this chart here, this is only a 10-minute window, but the blue CDN continued to perform well while the orange CDN had a big departure. So for this 10-minute window, for best quality for your end users, you'd want to switch your orange users over to be using your blue CDN. So this gives rise to content steering. So say we have a population of players that have a choice between two CDNs, A and B, both are advertised with base URLs. I now connect them to a steering service. This is a third-party service that's independent of the manifest but is referenced within the manifest. Now, if there's a slowness or a problem with CDN A, my steering service sends out a signal and all of my connected players at the same time will switch over, or at a staggered interval, depending how we want to do it, will switch over to CDN B. And conversely, that's if I want to move them in response to a delivery problem. But if there's some other reason that I want to move them, I can send an instruction and all of them would move back to CDNA. So it's a means of controlling a population of players in a deterministic manner. So who did the work to actually standardize this? This is a group called the Dash Industry Forum. You can see the 60 companies and some of the logos on the right-hand side. And it's a group that's been in place for 10 years now, trying to catalyze the adoption of MPEG Dash in the beginning, but more importantly now trying to solve some of the problems and improve the performance of Dash-based delivery. So Dash IF has been working on content steering. There's a spec that we've authored as a candidate technical recommendation. It's actually been out for community review. There's a number of companies supporting it, and we got a lot of feedback. So we're in the midst of revising that spec. What I'm talking to you about today is the very latest thinking of how it should work after considering all the feedback we got from that first community review. What will probably happen is that in short term, we'll publish a second community review, a second candidate technical recommendation, and eventually Dash IF will publish this and submit it to MPEG as a proposal, because MPEG are the authority, they're the group that actually issues the Dash standard. So let's go into how it works then. It does leverage base URL. We mentioned base URL is an existing mechanism in the manifest to point at two alternate sources for the content. Now there's a rarely used and quite forgotten attribute within base URL called service location. That's essentially a label that we can use to differentiate between these base URLs. So if I add service location here, I've called the first CDN, I've called it alpha, and the second one, I've called it beta. This will allow us to differentiate between these two base URLs in our content steering. And then we're going to add a new content steering element to Dash. So it's called content steering, and it's got a number of attributes. The first is something called the default service location. This, remember those service locations are labels? This is basically saying, hey, I would like you to use this label as your default base URL when you start. It's an optional attribute. The player can make a choice of which one it wants to use, or it can follow this instruction. There's got another attribute called query before start. This is going to instruct the player that before you make any decision in this manifest, I want you to resolve a response from the steering server. Now, the steering server is given as a URL in the content steering element. It's simply a URL that points to the steering server, and this instructs the player, go make a request to that steering server before startup. So here we see an example dash manifest. We got our base URL with two service locations, alpha and beta up here, pointing at two CDNs. And here's our new content steering element. This one tells you that the default service location is in fact beta. So this player should go start with beta in the beginning and not with alpha. And it's also query before start is false, so it can make its own decision on how it starts up. And there's the URL pointing at the steering server. It's actually quite simple in practice. Also note that this content steering element must be the last element in the MPD. This is because of the priority with which dash manifests are parsed and interpreted. Periods are sequential based upon their position in the manifest. So put the content steering element right at the end. Now, if you know the streaming industry, Apple did release content steering for HLS back in November 21, and I'll give you a reference to the spec here. And within their spec, they defined a content steering server response. So since Dash implemented this after Apple, we have some desire to preserve interoperability. We don't want you to have one steering server to steer your HLS population of players and another for your Dash. So we decided to make our solution as much as possible compatible with the steering server response already defined by Apple. So here's the steering server that we see with HLS. This upper portion is going to be supported as it is directly with no changes by Dash. The lower portion, which is pathway cloning, we don't need in Dash because we have a different mechanism for introducing new pathways midstream, which is the ability to update a manifest. Dash player will update the manifest at a predefined interval, and in that interval, we can inject new sources or base URLs for the content. So we don't need to clone existing pathways as they do in HLS. So we support the upper portion of the HLS response, and the Dash player simply ignores the pathway cloning. So what does the server response look like in a little bit more detail? It's a simple and pretty concise JSON document. So the version is required. There's only version 1 at the moment. TTL is the number of seconds since you must come back and revalidate the steering server response. The URI is the URI. You should do that. It may be a different one, and in many cases, I think it will be because we want to sessionize this behavior. And then lastly, the pathway priority, which is just an array of those service location identifiers. So in HLS, you call them pathways. In Dash, you call them service locations, but they're at the same identical thing. So here's what it looks like in the real world. Version 1, come back in 30 seconds, use that URL, and here's a list of my labels for my service location. So my service location priority, 1 is the highest priority, 4 is the lowest priority. So let's walk through player workflow then and see how this might work in practice. So step 1, the player gets a manifest. We notice in our manifest there's 2 base URLs labeled alpha and beta pointing at different CDNs. Down here is our content steering element. So the default service location is beta in this case, but we've told it query before start is true. If query before start was false, then it would simply start with beta. But in this case, it's going to honor the instructions. So the next thing it does is make a request to that steering server URL. We don't attach any dash parameters, and I'll get to what these are later because this is the very first request to the steering server. The steering server will then come back with a response, and we can look at this. So now we notice in the pathway priority here that the highest priority is alpha, not beta. So in fact, this player will start using alpha and not beta. It's also telling us to come back in 300 seconds. So we set a timer and we go back in 300 seconds after that. And we're going to go back to this URL and notice the steering server has added in a session identifier. This is so the steering server can keep track of this session over time and separate it from all the other sessions and be able to count and enumerate all the sessions that it is steering out there on the internet. And then in step 3, so we wait our 300 seconds, we go back. But now when we go back, we add in these 2 required query args, _dash pathway, which specifies the current service location, and _dash throughput, which specifies the current throughput in bits per second. And in HLS, if you know that content steering spec, this is called _HLS pathway and _HLS throughput. So we didn't want to masquerade as a HLS player. That's why we use _dash. So the steering server can clearly see this is a dash player that I'm steering, but we provide exactly the same information. So we go back to the steering server, it comes back with a new response, And now we see that the TTL has changed from 300 to 250. That's at the discretion of the steering server. And that beta is now the highest priority. So it would then switch to loading from beta instead of alpha. And that cycle continues for as long as the media player is playing the stream. So you may be asking at this point, well, what happens if the player encounters a delivery problem in between these steering decisions? And that's a valid question. So the first rule is the player's job is to try and maintain the best quality of experience for the end user. So what it should do, it can abandon, at least in the Dash world, it's allowed to abandon the last instruction it was given for the service location it should use and try the next highest priority service location that it got from the steering server. And then when it goes back to the steering server, it lists the pathway that it's playing on, which is the service location. The steering server will notice that it's not playing the one that it last assigned it. And therefore, it will know that's a signal to the steering service that there was a problem. The player also then blacklists the offending service location for a time period equal to the RTT of the steering server. Blacklisting means that if it gets another instruction to play from that CDN, it will process that list of arrays as if that blacklisted service location is not present. And once that timeout's expired, then it's free to try the offending service location again. So we don't use a lot of problems with CDNs are quite temporary. They might go away in 1 minute, 10 minutes, or half an hour. So we do want to retry at intervals if it is the preferred CDN. So the player's job is, again, do the best it can, and if necessary, work its way down that list on its own and autonomously. Another question that's interesting is, can we steer ad content separately from the primary content? Or is it steering only for the primary content? And the answer is yes, we can steer ads as well. So on the right, I have a manifest, and I've decorated it, the various periods, with colors. So the blue periods are the primary content. The green periods are the ad periods that are present in there. And notice the ad periods also carry their own base URLs, and the primary content carries a base URL up here. So in the steering server response, we can have a pathway priority that lists a bunch of possible service locations. And all that happens is, as the player is playing through its periods, it reevaluates the base URLs that are current for that period against this list. So right at the start to play it, we would notice that segments 2 is at the beginning. We would start playing with base URL segments 2. As we hit the ad, we're actually going to use the ad source it's ad to, because that's the next highest priority that matches inside this list. Same for the next ad period, we're still stuck with ad 2, and here suddenly we go to ad 3 because it's a higher priority than ad 4. So it's quite convenient with a single steering server, assuming it's controlled by the content distributor. We can use it to steer the primary content and any ads that are inserted into that content. And lastly, can we also steer the manifest refreshes themselves? Or do we always going back? What if the CDN that's delivering the manifest is performing poorly? Now, in a Dash MPD, there's an existing function to define alternate locations for the actual manifest. That's the location element. And what we're going to do there is add in the same label that we have in the base URL. We're going to call it service location. So now we can see that our steering server, again, in their service location priority, it can simply give a list. We reevaluate it against the location. So we would, in fact, use location MPD2 and the base URL segments 2 for our content. So that would instruct this player to go back to a new location when it did its manifest refresh. So we can steer ads, and we can steer the manifest, and we can steer the content. Now, there's one idea to define this content steering response into a separate spec. And if you think about it, this might make sense. In HLS, they have a normative definition for what this content steering server response should look like. Dash also has one, and we happen to make ours match the HLS one. But neither spec addresses some problems. And when you get into trying to make this work in practice, these become issues. Like, can we add weights to the priorities, right? Or are they strict priorities? What if we want to send additional metrics like player buffer length? There are other signals besides throughput that we might want to encourage a player to switch to a different CDN. How can we signal pathways with problems more explicitly? How do I deal with non-200 responses? And what if I use multiple pathways? In that the ad example I just showed you, there would have been multiple pathways used over 300 seconds. And which one should I report? So we've looked at this problem in CTA Wave, and basically we're going to propose to Apple that we might want to set up content steering the server response as a separate spec that's outside of both the HLS spec and the dash spec. The HLS spec can focus on how the HLS should react in response to the content steerer, and the same for dash. But then we can have a spec that's all about content steering, that's agnostic for the protocol it's steering, and we can start addressing some of these issues. We're not certain we're going to do this, but this is just the intent as of now. Now I'd like to show you this working, so I built a little test bed to demonstrate this. So instead of using two CDNs, because it's easy for me, I have one CDN, but I put up two repositories on the same CDN called A and B, and I've put copies of the content. Now normally you put a unique copy, the same copy is distributed to multiple parts, but in this case to demonstrate two CDNs, I've encoded each copy of the content with an overlay to indicate is it CDNA or CDNB. Then I'm using Dash.js Player. This is an open source player where they've done the work to integrate an early version of content steering. And many thanks to Dash Industry Forum and Fraunhofer for doing that work. And then I'm running a Node.js steering server on localhost so that we can see it running and I can control the behavior. Right, so this is a screen recording then of multiple players. So up here we have the Dash.js player with content steering enabled. To the right is the network panel for that player, so we can see where it's requesting. Bottom left is my steering server. I'm going to fire it up and get it running and listening on Node. And then over here is a little API I can use to change the priority. So it's set to alpha. I'm going to change it to beta. And you can see down here that it's changing over to beta. Then we need to look at the manifest that we're actually going to give to our Dash player. So here's the manifest in a little more detail. We can see that there's two base URLs in it, alpha and beta, and they're pointing at two folders on this actual same CDN holding the overlaid content. Down at the bottom is our steering server. Now it's set up to default service as alpha, so it should start on alpha. However, I'm telling it to query before start. So it should ignore this alpha and it should go and query the steering server before it starts and to find out what content source it should use. So we'll come back here and we'll start our player. And it started on B, which is good. Now it started very quickly, but under the covers, what it did was make a request out to the steering server, which I had previously set to priority beta. We can see that it started up a new session there. It's tracking this player, saying it knows where it steers it. Here we can see the response it gave, and it gave it a response beta and alpha up there. We can also go check the manifest. When it makes the next manifest response, it's returning the session ID, and there are those parameters we spoke about. What's the throughput, and what's the current pathway that it's using. So I can come back here, now switch my steering server to alpha. I've set up the steering server at a 10-second loops because we don't want to wait forever to see a response. In practice, Apple recommends 300 seconds. I think something like 30 seconds might actually be more reasonable. But we can see that it's already switched, the player already switched over CDNA. And it was a seamless transition, right? There's no loss of audio or video while it's switching between these CDNs because it's essentially the same content repository, just being delivered in two different parts. And we can validate that it is in fact loading from that path. And then just to demonstrate lastly the steering, I can come back, I take it from alpha down here, switch it over to beta. We see that it's processed an admin request in our steering server. Now it's going to wait for the player to come back. It's both got to pick up that steering server response. We can come and check that it's loading content. We want it to load from beta, and there we see once it's buffer, it's played through the forward buffer on the content. We notice that our B content is there. So that's content steering very simply, but working, and working in Dash.js. Now there are some current items of debate. Should the steering server be called just before entering a new period? The reason is there might be advertising content there that's dynamically positioned, and we might not have a reference to it for our steering server. So there's some thinking within Dash.js this might be a good idea. We haven't decided if it is, but it might make sense. And there's some complexity around this of how far ahead of the new period do I do it? We had a lot of debate over Xlink and how far ahead you could call it. The same would be true for content steering. What about DVB? In their variant of Dash, they define a pretty complex combination of weights and priorities, which allow a player population to switch over between different base URLs. but they're not in a coordinate fashion, but a strict rules for doing so. The current thinking on this is that you should not use content steering and the DVB solution because they're two approaches to the same end, and they're really not that compatible with each other. So that's something we might need to formalize in the spec. And DVB may want to use content steering. It wasn't available when they formed their spec, and they may want to adopt it as an optional mode for DVB-based distribution and control. And then what about throughput and pathway if you've used more pathways? And the example comes in with advertising. So I think there's a number of issues we still need to resolve before we can complete the spec. How can you get involved? Well, you can file issues against it. This is public on our GitHub. You can look when we go out for second community review and give us feedback. And then if you're not in Dash-IF and you do use Dash, you can join it. It's a bunch of people sitting down and solving problems. And we'd love to have you be part of this solution. And with that, I want to thank you. I hope you can use content steering. I look forward to feedback, and I appreciate the time you spent watching this today. Cheers.